Hello, so in this video I will talk about force and we will discuss about x, y, z components of a force. Say we have some body of mass m and say we have some force in this direction f and say this direction is x. So the component of force along the x axis is F and the component of force along y axis will be 0 and component of force along z direction will be 0. Now assume we have the same body of mass m and we have force along y direction alone, then we have Fx force along x direction will be 0, force along z direction will be 0, but force along y direction will be F, the magnitude of force being applied along force along direction y. Now let's take another example. Now instead of applying a force just along x, y or z, say we are applying force in certain direction. Say the direction is 30 degree inclined with x axis. So we will have now two components and say this force is being applied in xy plane alone. So this will have now two components, one will be Fx, another will be Fy, and Fz will be 0 because the force is being applied along the xy plane. So along the x axis, if we want to calculate the component, this will be F cos 30. Whenever we have certain force and have 30 degree with this, the component of this force along x direction will be F cos 30 and along y direction will be F sin 30. So Fx will be F cos 30 and Fy will be F sin 30. So this is we know 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. The sine values are 0, 1 by 2, 1 by root 2, root 3 by 2 and 1, and cos values are otherwise, which is 1, root 3 by 2, 1 by root 2, 1 by 2 and 0. So we have F cos 30, that will be root 3 by 2 and sin 30 will be F by 2. Now say if we want to calculate and we want to see that what is the net force, the formula for calculating the net force is under root of F component x square, F component y square plus F component z square. Now if you square it, you get F square 3 by 4 plus F square 1 by 4 plus z component is 0. This makes it net F, which is equivalent to the net force which is being applied. So this is about how to divide a force into different axes x, y and z. I will also talk something about what is the definition in terms of momentum. So the net force being applied is change in momentum vector. Keep in mind this is a vector quantity and rate of change of momentum vector with respect to time. So we want to see, say this is say this is p1 vector at certain instant time t, and instantaneously certain after time, say t plus dt, this is the vector. So say this is p2 vector. So now if you want to calculate the dp vector, which is basically change in the momentum vector, which is p2 vector minus p1 vector. So we have p2 vector along this direction, which is like this, and we will basically, what we do is p2 vector plus we will add minus of p1 vector to p2. So this is p2 vector, and we will add minus of p1. So minus of p1 is reverse of this, so this will be like this. So the force would be along this direction. So this is the direction of force, and the time it takes, it will calculate magnitude of that. So if you want to calculate the magnitude of this net vector, so you basically take the modulus of rate of change of this, and so the length of this vector is basically equal to p2 vector minus p1 vector and modulus. So this is p2 vector minus p1 vector by a small time dt and the modulus of this. So this is basically the magnitude of force, and this is equivalent to F is equal to ma. And how it comes, you can basically see that m is a is acceleration, which is change in velocity vector with change in time. So this makes it m dv vector. If you multiply them, it makes it mass into velocity change. That is basically, you can take mass as constant. Since the mass is constant, you can take it inside, and then this becomes dp vector by dt. So that's all for this lecture. I will discuss more about the force and center of mass and many more concepts in the later videos.